video, we're going to be covering the oxidation of alcohols. In the last video, I went over different classifications of alcohols. We went over primary, secondary, and tertiary alcohols. And in this video, I'm going to show you a type of reaction that primary and secondary alcohols can undergo. And this is called oxidation, and we'll look at some functional groups of an aldehyde, carboxylic acid, and a ketone. So first of all, I want to say that what oxidation is where an alcohol is reacted with an oxidizing agent. For example, and now oxidizing agents we represent in this bracket below, but it's typically potassium dichromate 6, which is K2Cr2O7, and sulfuric acid. Now, tertiary alcohols, for example, it's right here, will not undergo oxidation reactions, and that's because they're just not commonly oxidized by they're not oxidized by common oxidizing agents. Cool. So there are 3 different reactions. Two of them we'll talk about now. We'll consider the compound butanol, and the reaction conditions in order to turn this butanol into an aldehyde is with gentle heating, distilling, and by using an oxidizing agent. So if I draw out this equation for you, right here, K2Cr2O7, and I'm just drawing all the reagents and conditions on this arrow here. And of course, a byproduct of all of these reactions will be water. So, what can we see? What can we see here? Well, we can see that our alcohol group is obviously reacted in some way with this this oxidizing agent, and we've now got our aldehyde functional group. And so this was butanol, but this now is butanol, and obviously water. So this is the first reaction. Now, this aldehyde here can be further oxidized. And what I mean by that is we can react it again with these oxidizing agents, but different conditions are needed. And these conditions are again the oxidizing agents, but we now need to heat this in a reflux setup. And by reflux, I mean the constant boiling and condensing of a reaction mixture. It essentially just makes sure the reaction goes to complete. And as a result of this, we will form a carboxylic acid. So we've started out our butanol. We've now distilled this with oxidizing agents. We've reacted it with the oxidizing agents, and then we've distilled off the butanol product, and then we're essentially reacting it again with the oxidizing agents, but we now have it in this reflux setup. So we've gone from butanol to butanal, and then from butanal we're going from butanal to butanoic acid, and obviously water. Now you can also just go from butanol to the carboxylic acid, butanoic acid. And that's by just having this reaction in a reflux setup and reacting it with an excess amount of acidified potassium dichromate, H, and then plus our water. And for any oxidation reactions, just know that the observations are just going to be a color change from, this isn't exactly orange, but it's a color change from orange to green, like so. And then the final reaction we just have to look at here is something that forms a ketone, and we're going to be looking at a secondary alcohol. So we're just reacting it with our oxidation agent. This is also under reflux. And our oxidation agents here are the same: acidified potassium dichromate and sulfuric acid. This is under reflux setup, and this time we're going to end up with a ketone, which is just this double bonded O right here on a secondary carbon, the byproduct of water. And this here would have been butan-2-ol, and our products here would have obviously been butan-1, like so. And obviously this also goes under the color change of orange to green, like so. So I hopefully I've explained this reasonably well. You guys, I'll be going in depth in all of these reactions that I've been doing recently in another huge video that I'm planning. So thanks for watching.